While Podman can be a drop-in replacement for Docker on Linux machines, it's not merely a clone of Docker. Let's look at some of the features unique to Podman. The first feature is already hidden in the name. Similar to Kubernetes, Podman has pods. Pod is a group of multiple containers that share the same network namespace and are deployed together. Let's give them a try. First, we create a new pod by running podman pod create command and then passing the name of the pod. We can see the running pods by running podman pod ps command. This new pod has only one container inside, the so-called infra container. Just like inside the Kubernetes pods, the job of this infra container is to keep the pod alive together with all the required namespaces. This infra container is even using the Kubernetes pod image. The status of the pod is created because there are no useful containers in it. We can add a new container to this pod by running the podman run command and passing the pod name. Ignore the label part for now, we will get back to it in a bit. Let's run another container, this time with HTTPD inside the same pod. Now let's enter the first container with podman exec, the same command as docker exec more or less. If we now try to access the port 80, we will get a response from the HTTPD. Again, just like in Kubernetes pods, containers inside the pod can talk to each other over the localhost. We cannot access this HTTPD from outside the pod because we did not map any ports. Ports are mapped on the whole pod, and we have to recreate the pod to do this. Creating pods by hand is not the most convenient way, which brings us to the next Podman feature, Podman generate command. Podman generate can take an existing pod and generate either a systemd unit or a Kubernetes YAML for it. Let's generate the systemd unit. We need to run podman generate systemd and then the name of the pod, and we specify that we save it in the file. The result will be 3 different systemd services for 3 different containers. Keep in mind that pod is just an abstraction. What we think of a pod is an infra container that holds different namespaces that are then shared with multiple other containers. We can see this relation in these systemd files, where 2 services depend on the pod service to start first. You can also generate the pod YAML definition from podman pod and, in theory, use it inside the Kubernetes cluster. In practice, this YAML file will always be too far from what you would want for an application running on Kubernetes. Let's stop all the containers in the pod with podman pod stop command and then remove the pod. Then move the generated systemd units to a place where systemd can find them. That can be your user systemd services, it doesn't have to be a global root level unit. And now we can start the pod by starting the systemd unit. Again, I'm passing the user option to specify that that's the user systemd unit, not a system global one. If you check the podman ps now, you will see the containers for this pod are running. Remember that label we've set? This label tells Podman that this container should be auto-updated. To achieve this, I first need to log into Docker.io with my username and password. Afterwards, I am going to tag our image with docker.io / case shrinking / dockerless curl. And then I will push this image to the Docker.io. After it's pushed, I can run podman auto update and it will find every container which has this auto update label, and it will check if there are new versions of the images that this container is based on. And if there is, it will pull it and it will restart the container eventually. This is quite handy for patching containerized system services. You only need to make sure to run podman auto update as a systemd timer or a cron job. Those are some of the features specific to Podman itself. There are many others, like a REST API that allows remote clients to manage containers. Many other features are similar to Docker, but with slight differences. There are, for example, health checks for your containers, as well as the Podman machine that enables you to use Podman on Mac and Windows. Podman even supports Docker Compose files. You only need to install the Docker Compose tool, and then it will properly create containers from the same compose file. Keep in mind that Docker Compose is an extra Python utility that does not require the actual Docker daemon to be installed. In the next video, we will sum up the Podman discussion.
Do you think your project infrastructure is well set and maintained? We know for sure there is always room for improvement. If you are uncertain where to begin, let's first do an audit of what you already have. We will review your setup from every angle: performance, cost, security, high availability, automation, and provide you with a detailed roadmap of which direction your infrastructure should go, generate concrete tasks for you to implement, or even take on your infra entirely, if you let us, of course.